We can define what a circle is. A circle is the set of all points in a plane that are the same distance from a given point. So the same distance from that center point is called the radius. We also can talk about other parts of this circle. An arc is any part of the circle that can be drawn without lifting a pencil. So arc CD is in this picture here. I could draw that without lifting my pencil. I could also talk about what a chord is. A chord is a segment that has endpoints on the circle. So CB is a chord. CA is also a chord, but it is a diameter. So a diameter is a chord that contains the center of the circle. So we can talk about minor arcs and major arcs. So remembering that an arc is a part of the circle that we could draw without lifting our pencil. A minor arc is one that's determined by a central angle whose measure is less than 180 degrees. So AB is a minor arc in this picture, because the measure of the angle, the central angle, the angle that goes from B to the center of the circle to A, is less than 180 degrees. So that's why it's called a minor arc. A major arc is determined by a reflex angle whose measure is greater than 180 degrees. So arc ACB, so if I use green, that is going to be the arc all the way around from A through C to B. That's a major arc because this angle, if we go around this way, that is greater than a 180 degree angle. So depending on a context, the central angle and its associated arc have the same degree measure. So an arc is determined by a diameter is a semicircle. So a semicircle that is going through the diameter, or excuse me, an arc that's defined by the diameter is our semicircle. So AD here, arc AD defines a semicircle because it goes, it's defined by the diameter. So we can find the measure of arc AB that's associated with the central angle AOB. So to find the measure of arc AB, which I'll highlight here, arc AB is this arc here, and it's defined by or associated with the central angle AOB. The measure of the arc is the same as the measure of the central angle it's associated with. So we're looking for the measure of this angle here. There are several different ways you could figure this out, but the simplest is probably to think about line FB, or the diameter FB, as a line, and remembering that lines are straight angles that have a measure of exactly 180 degrees, I know that this measure is 180 degrees. So I could subtract 60 from that measure and I would be left with the difference of the angle that I am looking for. So I would say that the measure of arc AB is 180 degrees minus 60 degrees, or 120 degrees. We could also say we want to find the measure of arc AF. So AF is this arc here, and it's associated with angle AOF, and so that one's already given to us. It is 60 degrees. We could also ask about the measure of arc BC. So this is the same measure of the angle BOC. There are, again, many different ways we could use to figure out what this measure is. We already know that this measure was 120. And similarly, this measure is 120. We could do the same thing with our line. And then we could think about the vertical or the line or diameter FB to see that this measure would be 60. But we also know that 60 angle AOF and BOC are what we call vertical angles. They are angles across from each other across intersecting lines, and they are then going to be equal. So, and the measure of arc BC is 60 degrees. Then we can also ask about arc FDC. So arc FDC is going from F to C through D. So this is associated with the angle FOC. So we need to find that angle measure, which I just said on the last slide was 120.